In this section of the video, I'm just going to talk about when to use the z-table. Basically, there's two general sets of times when you'd use the z-table. One is when you're given a normal population and you're computing probabilities with respect to a value or set of values in that normal population. And the second is when you have a bell-shaped sampling distribution. The one we've talked about so far is the sampling distribution of x bar. There will be others as we move forward. So here was that first one, a normal population. You'll be given a mean, mu, and a population standard deviation. And you're talking about a distribution of x's. Please make sure when you draw these that you have the correct labeling, that it has x on the x-axis, and that you have mu and sigma for the parameters of the population. For sampling distributions, I'll talk here mainly in terms of the distribution of x bar, but again, there will be other sampling distributions as we move forward. Remember that we'll have a bell-shaped sampling distribution if the sample size is large enough, and also remember that it's going to be narrower than the population from which it was drawn, and it's narrower, or the way you can measure that is to take the standard error. You take the population standard deviation, divide by the square root of n. So here's just a picture then of a sampling distribution. Again, make sure that you have the correct labeling on the x-axis. Now it's x bar. It will be other things later, but it'll be different statistics. It's the distribution of x bars here. And so you have the mu, the mean of the x bars, which, as we know from last time, is equal to the mean of the population. And then you have the standard deviation or standard error of the x bars. And again, from the central limit theorem and last time, we know that that's going to be equal to the population standard deviation divided by the square root of n.